folks. Good afternoon. I hope all of you can see me and hear me clearly. I hope the tech is working fine. I hope the volume is fine. Rest of it. I can see quite a few of you have tuned in and you're chatting away. Good evening to all of. Good afternoon to all of you. Just somebody could sign off and say, "Hey, the audio video are working fine." I'll be thrilled. Be very happy. And hopefully, you can see me and hear me clearly. Just want to verify that, and then we'll jump in and start discussing this. Good day to all of you. Good Sundays are always good. It's not great that you're having to do something academic on a Sunday, but in that context, PiMO is probably the most fun thing that you can do, and it's tons of good learning, lots of fun, enjoying the session. I can tell you this, we will make sure that it's a lot of fun discussing these questions, and you'll be better equipped to handle similar questions like this, and so it should be fun. It's working. Sure. Shweta's simple world. Thank you for saying it's working. Javid saying thanks for saying video is working. Audio is also working. Hari's binary is clear. And if binary is saying it's working, it's most definitely working. There's no halfway. It's either working or not working. Both audible and visible. Chayanika Mandal, thank you. Audio video are working. Ragini Ramurthy, thank you. Thanks all of you. Sushil Kumar, namaste. Thank you. Manoj Chubaji, school exam on a Sunday. It should be illegal to have school exams on Sunday. Some other competitive exam I can. Today is a fine morning to sit back and see our results. Today is a fine morning to learn new ideas, my friend. Not to sit back and see results. Sitting back and seeing results is a very incidental part of the scheme. So don't get consumed by this results watching gig. So I several times I find students to be fixating over or thinking about what is the mark, what is the number, how much scores obtained, all the rest of it. And I find it sometimes distressing to note that the number or the mark or the score is considered more important than the idea of learning something. I'm just checking my tech here. I have a dummy screen to see if everything is working on fine. And so I know all of you are curious to enjoy and know about the marks. I know we are in what is called as a scarcity economy. And India is a developing country. So there are so many people for that slightly fewer than optimal resources. And so if you think you're living in a scarcity economy in 2022, 25 years ago it was worse. 25 years further back it was far worse. And so we've come a long way from those eras. So our attitude should also change. And when we were growing up, every half mark, 1 mark mattered because we used to think that, hey, this is going to be a determiner for success. And our parents used to say, if this 1 mark goes back, God knows which college you will end up with. As parents now, we are telling you that every half mark, 1 mark is not so crucial. Every 2 things in one exam is not so important. The idea of learning sufficiently well, being confident of what you are about, being comfortable in your skin, and approaching the world with a sense of curiosity and awe, that is the thing to go for. And so don't get carried away and lose all the generational advantages you've got. Because as parents, I'm telling you, you should not be thinking about numbers and marks all the time. We used to do it. It drove us mad. It drove some of us really mad. I think our parents came from their era. And so I think now, for all the challenges with the virus and a struggling economy and bad situation, I think economically, a generation of Indians, this generation of Indians, is better off than anything that has gone before it, and substantially so. We should all be thankful for it and not still worry about this number and that score and this mark and all that. Yeah. So from today, worry way more about learning and being curious, and worry way less about this mark and that mark. This is a super fun exam. This is delightful paper. In fact, I discussed the paper for the class 5 and 6 kids in the morning, and that I thought was interesting. This is 1 notch even better than that. The questions are beautiful, super fun to discuss with. And there's nothing that gives me greater joy than discussing mathematics questions with young students like yourself. So I'm going to enjoy this. Can we proceed? So MSP Gen Gaming is even more impatient than I am, which is good. I'm just waiting. I just want to wait for a 4-minute, 5-minute window so that everybody who knows the session is happening, they can just come back and sit down, take their seats, be ready. And so it takes about a 3-4 minute window to get comfortable. And now all of you are here Right. Wonderful. So I'm going to jump in and start discussing these questions. I said this is the part I like, so I must enjoy this. What is the smallest multiple of 45 that contains the digits from 0 to 9, each appearing at least once? Each appearing at least once. That means we should have at least a 10-digit number. I'm confident we can find a 10-digit number, so I'm going to look for a 10-digit number. I have a 10-digit number. The digits that should be there are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm writing it like this because then adding becomes easy. 9 plus 1, 10, 8 plus 2, 10, 3 plus 7, 10, 4 plus 6, 10 plus 5. So sum of all the digits is 45. Why am I adding all the digits? Because I know the number I want to find should be a multiple of 45. If a number is a multiple of 45, then it should be a multiple of 9. It should be a multiple of 5. If it should be a multiple of 9, sum of the digits should be a multiple of 9. If it's a multiple of 5, it should end in 0 or 5. I know our number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10-digit number. I'm assuming we can find a 10-digit number. For some reason, we are not able to do that. Then we'll go to 11 digits and so on. 10-digit number should end in 0/5. One of these two. If I add all these digits, it comes up to 45. Sum of all the digits from 0 to 9 is 45, which is nice because then I know in any sequence I put them in, I'll get a multiple of 9. Whether I put as 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 or 1, 2, 3, 4, 0, 5, 6, 7, 9, 8, some sequence, whatever sequence I put these numbers in, the sum of all, if all 10 digits appear exactly once, I have 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, all of them appearing exactly once, then I know that sum of all digits is 45, the number is a multiple of 9. I'm done. So I need to put the smallest possible sequence with 0 right at the end. How do I do that? I start with 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. It should work. Can I do even better than this? I started with 1, I've gone in ascending order. Smaller digits go in front, larger digits come at the end. The problem here is I put 0 right at the end. 0 is a very small digit. I cannot start with 0, but I can have 0 right up front except for this one. Or I can do 1, 0, 2, 3, 4, 5, 6, 7, 8, 9. No. The moment I do this, my last digit becomes flawed. My last digit can only be 0 or 5. So what do? I say, hey, 1, 0, 2, 3, 4, 6, 7, 8, 9, 5. My last digit being 0 is the best case scenario. My last digit being 5, this is the best case scenario. This is better. This starts with 1, 2, 3, 4. This starts with 1, 0, 2, 3, 4. It's definitely better. This is my smallest 10-digit number with 10 distinct digits that happens to be a multiple of 9 and of 5. The 10-digit number which has all 10 digits will definitely be a multiple of 9. I don't have to really worry about it. Sum of the digits is 45. If I put 0 right at the end, I get this number. If I put 5 right at the end, I can put 0 much up front. That's my best case scenario. So 1, 0, 2, 3, 4, 6, 7, 8, 9, 5 is my multiple of 45 that I'm looking for. This is the number. Beautiful question. Wonderful. I think you guys have got this funda and you're comfortable and happy with it. I'm going to go to the next question. X square minus 17 whole square is 64. Whole square, the number into itself. First of all, I want to know number into itself. So 1 into 1 is 1. 2 into 2 is 4. 3 into 3 is 9. 4 into 4 is 16. These are all called perfect squares. I've got a 64 sitting there, which is very nice. But then I can know what into what is 64. 8 into 8 is 64. Nice. So x square minus 17 into x square minus 17 is 8 into 8. Brilliant. So I say, hey, nice, interesting. That means x square minus 17 should be 8. I mean, x square should be 8 plus 17, which is 25. 1 into what is 25? This I know. 5 into 5 is 25. Brilliant. And then I'm through. So x equal to 5 works. 5 square minus 17 is 25 minus 17, 8. 8 square is 64. What have I missed in all this? What have I missed in all this is something that human beings missed for a while. and several in our education system, it comes nicely slowly. They teach all of us, they teach about 1, 2, 3, 4, 5. Then they put 0 in and say these are whole numbers. Then they say you'll have to think about 1 by 2, 1 by 3. Then they say you have to think about -1, -2, -3. The beautiful integer part of the number line, which is a negative part. We've forgotten that. How am I saying we've forgotten that? 8 into 8 is 64. Yeah. If you say a number into itself is 64 to a 9-year-old kid, the kid will probably say 8 into 8. If you say that to a 15-year-old kid, he should say 8 into 8 is 64. Minus 8 into minus 8 is also 64. I know I have to worry about that. X square is 25. 5 into 5 is 25. Minus 5 into minus 5 is also 25. So now I have to worry about both of these. So what do I say? So x square minus 17 into x square minus 17 is 64. This could be 8 into 8, or x square minus 17 into x square minus 17 could be minus 8 into minus 8. So x square minus 17 is 25. X square, sorry, is 8. X square is 25. That means x could be 5 or minus 5. Or x square minus 17 is minus 8. X square is 17 minus 8. X square is 9. Or x could be 3 or minus 3. 3 minus 3, 5 minus 5, all of them work. Or how many integer values of x satisfy this equation? 4 of them. If you've got only x equal to 5, then you're not opening up your mind to the possibility that x could be minus 5. If x into y is 12, it could be 3 into 4, it could be minus 3 into minus 4. So we have to keep negatives in mind. If x square is 64, 8 into 8 is 64, minus 8 into minus 8 is also 64. You have to keep minus 8 into minus 8 into mind. So x could be 5, minus 5, 3, minus 3. All 4 possibilities exist. 4 possible answers are there. Very important, very crucial. A fundamental difference between thinking about natural numbers and integers. And you must think about integers. Therefore, minus 8 into minus 8 becomes super important. Wonderful. So minus 3 minus 5, 3, 5. Don't forget the minus part. Lovely. Let me go to the next one. Which of the following cannot be the ratio of the lengths of all these? First of all, the question where can be, I at least know what to do. How do I know cannot be? And I'm going to say, so some of these can be. I don't understand this question at all. If I know which of the following can be sides of a triangle, that I understand. I know that if you have a sides triangle with sides A, B, C, then I know A plus B should be greater than C. B plus C should be greater than A. C plus A should be greater than B. I know sum of any two sides of a triangle has to be strictly greater than the third one. Nice, I know that. There's no such rule for altitudes. I'm confused. I'm going to say, hey, this seems all interesting, but I'm going to figure out a way to deal with altitudes. I'm going to take a triangle. I'm going to take a triangle which has sides, say, 4, 5, 6. 4 plus 5 is greater than 6. 5 plus 6 is greater than 4. 4 plus 6 is greater than 5. This is a possible triangle. And I know that. And I know I have this triangle with me. I'm going to think about the altitudes of this triangle. Altitude is a perpendicular distance from the opposite vertex. So if I draw a perpendicular from here, or a perpendicular from here, or a perpendicular from here. Say this is ABC. AD is a perpendicular, BE is a perpendicular, CF is a perpendicular. I have to figure out some way of understanding these altitudes. First thing I'll say, I want to find the longest altitude and the shortest altitude. If I look at the diagram, if AB is short, it looks like this is going to be farthest from C. BC is long, it looks like AD is going to be shorter than CF. But I want to go better than that. Where do I really use altitude in? I know I use altitude in finding area. So area of this triangle is half into BC into AD. It's also half into AB into CF. AB into CF, BC into AD, AC into PE. Beautiful. Why? Because now I know using area, I can link the altitudes. How do I link it? Think about this. I'm going to erase some part of it and then rejig it in a slightly different way. I'll say, hey, I know therefore that BC into AD equals AC into BE equals AB into CF. Half of this is area, half of this is area, half of this is area. Area is a constant. Half of base into height is half of base into height is half of base into height. Or I know if BC is 6, 6 into AD is AC is 5, 5 into BE equals 4 into CF equals 2 times area. Half into BC into AD is area. BC into AD is 2 times area. Half into AC into B is area. AC into B is 2 times area. Brilliant. Brilliant. Why? Now I know for our question what I can do. I'm going to forget about 4, 5, 6. I'm going to think about a broader question. What do? I say, hey, ABC triangle. There is altitude, altitude, altitude. Altitudes are given to be in the ratio, say 1 is to 2 is to 3. I'm going to take that. 1 is to 2 is to 3. Or let's say this altitude is h. This is 2h. This is 3h. Brilliant. So what am I going to do? Half into BC into h is area. Or BC is 2a by h. Nice. Half into BC into 2h. 2a by 2h is a by h. Half into AB into 3h is area. Or AB is 2a by 3h. Likewise, we've done AB and BC. CA is 2a by h. H, 2h, 3h. Or I know if I have the ratio of the altitude, if I take a reciprocal of that, that will be ratio of the sides. Brilliant. This is super important. This is super important. 1 is to 2 is to 3. Altitudes ratios 1 is to 2 is to 3. Sides ratio is 1 by 1 is to 1 by 2 is to 1 by 3. Super important. Why? Half into base into height is area. This altitude into this side, 1 into 1, 1. This altitude into this side, 2 into 1 by 2, 1. This altitude into this side, 3 into 1 by 3, 1. All three heights should be same. And so if area were A, then altitude in the ratio 1 is to 2 is to 3, sides will be the ratio 2a by 1, 2a by 2, 2a by 3. Ratio of altitude is P is to Q is to R. Ratio of sides will be 1 by P, 1 by Q, 1 by R. P into 1 by P, area is same. Q into 1 by P, Q is 1. R into 1 by R is 1. Since the area is a constant, this altitude ratio gives us this side ratio. We are through after that. What do I need to do? I know all I need to do is 1 by 2 is to 1 by 3 is to 1. Can these be sides of a triangle? Sum of any two sides has to be greater than the third side. I'll add the two shorter sides up, compare with the longest side. So if I say 1 by 2 plus 1 by 3 compared with 1, this is 3 by 6 plus 2 by 6 compared with 1. This is 5 by 6 less than 1. This is not even a triangle. 1 is to 2 is to 3 is not possible. It is impossible. So the first one is my answer. It cannot be. Obviously, I'm a little unsure. I want to make sure that the other three are possible. So I'm going to check this out. 1 by 3, 1 by 4, 1 by 5. These are the two shorter ones. I'm going to add them up. 1 by 4 plus 1 by 5. This is 5 by 20 plus 4 by 20. 9 by 20. 9 by 20 is greater than 1 by 3. This can be the ratio of. After this, it's just very regular. 1 by 4, 1 by 5, 1 by 10. 1 by 5 plus 1 by 10 is 2 by 10 plus 1 by 10, which is 3 by 10. 3 by 10 is greater than 1 by 4. 3 by 10 is 30%. 1 by 4 is 25%. So this could also be the ratios. 2 is to 3 is to 4, 1 by 2, 1 by 3, 1 by 4. 1 by 3 plus 1 by 4. LCM is 12. 4 by 12 plus 3 by 12. 7 by 12 is greater than 1 by 2. This works. Sum of any two sides of the triangle will be greater than the third side if these are the ratios. Will not be greater than the side if the ratio were 1 by 2, 1 by 3, 1, or the altitude ratio cannot be this. The verification part is all right. The trickiest part is to recognize that if three sides are the ratio P is to Q is to R, three altitudes will be the ratio 1 by P, 1 by Q, 1 by R. If three altitudes are in the ratio A is to B is to C, three sides will be in the ratio 1 by A is to 1 by B is to 1 by C. Because half into base into height is area. So the area is a constant. So the side and height will have a reciprocal relationship. If one side is very long, the altitude will be short. If one side is very short, the altitude will be long. That's all we need to keep in mind. Right? Wonderful, wonderful question. Really tough question. So the first one, answer choice is the first one. The ratio cannot be 1:2:3. Lovely. I'm going to go to the next one. Somebody there saying C cannot be. It can be. 4 plus 5 is less than 10. But we're not worrying about 4 and 5, 4, 5 and 10. We're worrying about 1 by 4, 1 by 5, 1 by 10. 1 by 5 plus 1 by 10 is greater than 1 by 4. C is possible. Only A is not possible. Two power 18 is 262,144. What is the largest prime number that divides 262,143? Very interesting. 262,144, 262,143. This minus 1. I'm thinking about 262,143 is 2 power 18 minus 1. It is clearly hinted that this number is not prime. So I have to somehow factorize this. I know one beautiful factorization formula. I know a square minus b square is a minus b into a plus b. What I'm going to do this 2 power 18 minus 1 power 18. I'm going to read as 2 power 18 minus 1 square. 1 square. 2 power 18 is 2 power 9 whole square minus 1 square. Or this becomes 2 power 9 minus 1 into 2 power 9 plus 1. This idea, this technique, this way of manipulating is super important. 1 power anything is 1. So you can write 1 as 1, you can write it as 1 square, 1 cube, 1 power 4, 1 power 5, 1 power 18, 1 power 103. Anytime you have a 1, reimagine that as 1 power something, life becomes simple. 2 power 9 minus 1 is 2 power 9 plus 1. 2 power 9 is 2 cube whole cube. This is 8 cube. This is 512. This number is 512 minus 1 into 512 plus 1. Nice, brilliant, which is 513, 511 into 513. Nice, so far so good. Maybe these also have some prime sitting inside them. 5 plus 1 plus 1 is 7, so that's not a multiple of 3. 5 plus 1 plus 3, 6 plus 3, 9. The 513 is a multiple of 3, not just 3, it's a multiple of 9. What I'm going to do, I'm going to factorize this. 513 divided by 9 was 5 times 45, 7 times 10. So I've got my number, which is 262,143, written down as 501 into 9 into 57. 513 is 9 into 57. Brilliant. So my answer, the largest prime that divides us, could be 511, could be 57. It's not 3. 57 is, 57. 9 into 57. For 450, 9 into 763. 57 is also not prime. It is 9 into 3 into 19. Maybe 511 is prime, in which case 511 will be the answer. Or it could be 19. Or we say, hey, it is not 19 or 3 or not 511. 511 can be factorized. So now let's think about this. 511. It's not a multiple of 2, not a multiple of 3. It's not a multiple of 11. 13, we have to find 7. Let us try before we go further. 511 divided by 7, 7 times 49. Lovely, 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 lovely. We are through. 511 is 7 into 73. So this number 262143 can be written as 7 into 73 into 3 into 3 into 3 into 19. The largest prime that divides it is 73. All starting from the point that a square minus b square is a plus b into a minus b. Once we get that out of the way, we are through. We can go further down this road by saying we get this number as 2 power 9 minus 1 into 2 power 9 plus 1, which can be written as 2 power 9 minus 1 cube into 2 power 9 plus 1 cube. This is 2 cube whole cube minus 1 cube, or 8 cube minus 1 cube into 8 cube plus 1 cube. Some of you might know the factorization for a cube plus b cube. A cube plus b cube can be written as a plus b into a square minus ab plus b square. You may know the factorization for a cube minus b cube. That's a minus b into a square plus ab plus b square. We can factorize like that and simplify. But even that is not necessary. Once we break it like this, we can simplify it. Wonderful. So the answer is 73. Brilliant question. Very tough question. Based on the idea that you can think of a square minus b square as a plus b into a minus b. Infinity magma, is there a short method for this question? This method is probably the best method, approaching it very methodically. That is correct. Don't worry about shortcuts. If you get the answer right, you're doing well. You don't need to do it quickly. 73 it is. 73 is indeed the right answer. If you take 5 to 10 minutes on this one, you're completely fine. There's no need to do this any quicker than that. Lovely. I'm going to go to the next question. Two fair dice have faces numbered 1, 3, 4, 5, 7, 2. 1, 3, 4. 1, 2, 3, 4, 5, 7. Instead of 6, we have 7. When we roll both of them together, what is the probability that sum of the numbers on the two dice be an odd number? Sum of two numbers has to be odd. We know that odd plus odd is even. Even plus even is also even. Odd plus even is odd. Wonderful. We want the sum of the two throws to be an odd number. Sum of the two throws should be an odd number. Straight away I'm sensing that we need to look at these dice, look at those numbers and say, hey, I'm going to slot them as odd numbers and even numbers. 1, 3, 5, 7 are odd, 2, 4 are even. So I'm going to think about this. Possible numbers as 1, 3, 5, 7, 2, 4. I'm writing down like this. These are even, these are odd. Nice. I have one more dice here. I know dice don't look like this, but I want to see it like this. 1, 3, 5, 7, 2, 4. Imagine you roll this and everything else is hidden, only one number comes on top. You roll this, everything else is hidden, and only one number comes on top. I'm already sensing that I have to think in terms of odd plus odd is even plus even is even, odd plus even is odd, all of that. Right? So I'm bunching my 6 numbers into odds and evens. That's my starting point. So I'm looking at this number as 1, 3, 5, 7 one side, 2 and 4 this side, 1, 3, 5, 7 this side, 2 and 4 this side. Right? I roll all my numbers. What is the probability that some of the numbers in the two dice will be an odd number? When can it be odd? I select an even number here and an odd number here, or an odd number here and an even number here. Nice. First die has an even number, second one has an odd number, or first die has an odd number, second die has an even number. Or if I think about it, my two throws could be 2 and 1, 2, 3, 2, 5, 2, 7. 4, 1, 4, 3, 4, 5, 4, 7. So I could have put 2 and 1, 2, 3, 2, 5, 2, 7. Or I could have put 4, 1, 4, 3, 4, 5, 4, 7. Brilliant. The moment I write it down like this, I'm through. How? Because now I know the whole mechanism. I could have even here and odd here. 4 plus 4, 8 possibilities. Or I could have odd here and even here. Same 8 possibilities. 1, 2, 3, 2, 5, 2, 7, 2. 1, 4, 3, 4, 5, 4, 7, 4. 8 possibilities. Totally, I have 8 plus 8, 16 possibilities of the sum being an odd number. So far, so good. I want to find probability. Probability, I know what is the total number of possibilities. What have I listed down here? One number from here, one number from here. I've thought in terms of 2, 1, 2, 3, 4, 1, 4, 5. In those combinations, how many are possible totally? I could have 2, 2, 2, 1, 2, 4, 2, 1, 2, 5, 1, 2, 1, 4. Every single possibility from here combined with every single possibility from here. My total number of possible combinations is 36. Why? 6 into 6. Everything is possible. Of which how many work for me? 16 work for me. 2 into 4 plus 4 into 2. Out of these two even numbers, I'll get 1. Out of these 4 odd numbers, I'll get 1. So any even number from here combined with any odd number from here, that works. Any odd number here combined from any even number from here, that works. Totally 6 into 6, 36. I'm through. Right? So I'm going to reimagine this slightly differently. I'm going to think of it as 1, 3, 5, 7, 2, 4. 1, 3, 5, 7, 2, 4. So out of these, any combination will work for me. That is 4 into 2. One out of these two, one out of these 4, any combination will work for me. This 2 into 4. Any one out of this 6, any one out of this 6. 6 into 6 is a total combinations possible. That is 1, 1, 1, 3, 1, 5, 1, 7, 1, 2, 1, 4. 3, 1, 3, 3, 3, 5, 3, 7, 3, 2, 3, 4. 5, 1, 5, 3, 5, 5, 5, 7, 5, 2, 5, 4. All of them are possible. Out of those 36, these 16 work for me, 8 plus 8, or my probability is 16 by 36, just 8 by 18, just 4 by 9. Hopefully, that will be there as one of the choices, and it's indeed there, 4 by 9. That's the answer. Probability is not one magically difficult idea. It is out of all possibilities, how many work for me? There's a total number of possibilities. So if I can reconstruct this as this many possible options are there, and within that this subsegment work for me, what are the chances? 1 divided by the other. Out of this total pot, what subset works for me? 1 divided by the other, that's my answer. So answer is 4 by 9. Very, very doable question, even if you didn't know the first thing about probability. Lovely. I'm going to go to the next question. Nothing there. I was just having one look at the chat window to notice if there was something special or different. There's nothing there. Wonderful. So where does this leave us? This leaves us with a beautiful thought of a summer camp. And so we are coming up on the summer, not anytime soon. We still got another month to go, or maybe 5-6 weeks to go before your schools leave chutti. We have a beautiful summer camp lined up where we do a bunch of questions with very much like what you've seen in PiMO'. So we will have lots of fun, really challenging, atypical, unconventional, wacky questions, just like PiMO'. If you've enjoyed PiMO', then the summer camp is just an extrapolation of this. Take PiMO', multiply it by 5 or 6, you'll get summer camp. The advantage being, on top of that, We'll have an intimate group, a place to chat and enjoy the discussions. Have a work with a peer group rather than just be of YouTube. So we're going to give an outline about what is there in the summer camp at the end of this session. The session ends at 1 or maybe 1:05. It will become, because the remaining 5 questions are tougher. So please tell your parents to drop in at 1 or 1:05 and then listen to what is there in the summer camp, so they can get any doubts they have also clarified straight away. But you're going to have lots of fun discussing that and lots of fun in the summer. Right? I can't wait for that to begin. On to the next one. Oh, this is my favorite question. And so the story is brilliant. A bag contains 2021 white balls and 2021 black balls. And horrible year, 2021. Players A and B play a game with the following rules. On each turn, the player has to select 2 balls. The player selects 2 white balls, they replace with 2 black balls. Nice. The player selects 2 black balls, they replace with 2 white balls. Nice. If you get white, you put black. If you get black, you put white. So far, so good. The player selects 1 white ball and 1 black ball. They're replaced with 1 black ball. Take 1 white and 1 black, you replace it with 1 black ball. So there is a way. In this case, the same number of balls will remain. This is the outcome, same number of balls will remain. This is the outcome, the number of balls will reduce by 1. I get 1 black and 1 white. I'll replace it with 1 black ball. So there is a mechanism where there are 4042 balls totally. I keep on playing. After some time, I'll have only 1000 balls. I keep on playing. After some time, I'll have only 100 balls. Eventually, the number of balls will keep reducing. That's the idea. A wins the game if the last ball remaining is white, and B wins if the last ball remaining is black. Ball is white, then A will win. B wins if the last ball remaining is black. What is the probability that A will win the game? What is the probability that the last ball remaining is a white ball? Very interesting, delightful question. And so, what am I going to do? First of all, I'm going to say, hey, 2 white balls replaced with 2 black balls. There are 3 moves available. And so very interestingly, suppose this happens. Let's say play 1, play 2, play 3. And what is play 1? I select 2 white balls replaced with 2 black balls. What happens? The number of white balls reduces by 2. Number of black balls increases by 2. If I pick 2 white balls, the number of white balls reduces by 2. The number of black balls increases by 2. Nice. If I do this, if I pick 2 black balls, number of white balls increases by 2, number of black balls increases by 2, decreases by 2. I take the 2 black balls, replace it with 2 white balls. So far, this is very symmetric. Like if we kept playing this game, the probability of A winning or B winning cannot be wildly apart. 2 white, 2 black, same number of white and black. The exact same rules apply for white and black. If there are 2 white balls, replaced with 2 black balls. The 2 black balls replaced with 2 white balls. Nothing funny happening. Look at the last one. 1 white and 1 black ball replaced with 1 black ball. That means the number of white balls reduces by 1. Number of black balls remains the same. Beautiful question. What did we start with? We started with 2021 white balls, 2021 black balls. It looks like if you do this, then the number of black balls falls by, it remains the same. White balls reduces by 1. So in these two, maybe they'll just get cancelled out. But if you pick 1 black and 1 white, then the number of white balls falls by 1. Number of black balls stays as 0. Now I'm going to say randomly these get picked. Randomly. And I'm going to just put randomly. So maybe the first time this happens, then the white ball reduces by 1, 2019, 2023. Second time this happens, white ball increases by 2, 2021. Black ball reduces by 1, 2021. Then this happens, white ball reduces by 1, 2020. Black ball remains as it is, 2021. Then let's say this happens 5 times in a row. Minus 2, minus 2, minus 2, minus 2, minus 2, minus 10. This becomes 2010. This becomes 2031. Then say this happens 3 times. It becomes plus 6, minus 6. It becomes 2016. And this is 2025. And let's say this happens 3 times. It becomes 2013. This stays at 2025. Guys, I'm just saying, okay, these games are getting played. I don't know which one gets played first time, second time, third time, fourth time. I just keep playing them. This happens 5 times, one time, all of this. And notice the number of white balls remaining, number of black balls remaining, and see if there is some pattern that you can observe. Very, very important, very crucial, beautiful pattern is there. The number of black balls can increase by 2, decrease by 2, or be 0. In any time, and any whatever happens, if I have n number of black balls, it can become n plus 2, n minus 2, or remain as n. There's a beauty to this. If I had n black balls to start with, my number of black balls can become n to n plus 2, n to n minus 2, or stay as n. Brilliant. So, I have 2021 black balls to start with. If you look at all of these numbers, plus 2, minus 2, stay as it is, plus 10, minus 6, stay as it is. What is happening here? Each move, this goes up by 2, comes down by 2, or stays as it is. Or the change is always plus 2, minus 2, or 0. I'm trying to convey one very important point here. 2021 is an odd number. I add 2 to it, I add 4 to it, 6 to it, 8 to it, 10 to it, 12 to it, it will remain an odd number. I subtract 2 from it, subtract 4, subtract 6, subtract 8, it will remain an odd number. I do nothing to it, it will remain an odd number. If this gets played 1000 times, this gets played 1300 times, this gets played 3600 times, the cumulative impact, I don't know what the answer will be, but I know the number of black balls will be an odd number. Why? I add 2, subtract 2, I keep it as it is, add 2, subtract 2, add 5 times I add 2, 5 times I subtract 2, 10 times I do nothing to it. I'm either doing plus 2, minus 2, or 0. The number of black balls can never become an even number. I have an odd number, I add 2 to it, it will be an odd number. I subtract 2 from it, it will be an odd number. I keep it as it is, it will remain an odd number. No matter how many times I do plus 2, minus 2, 0 in whatever order, any time random, it will never become an even number. So, the number of black balls can never become an even number. That's super powerful. Why is it super powerful? The number of black balls, therefore, can never become 0. So, what will be the last ball? If you keep on playing this, maybe it will drive you mad. Maybe it will tell you play for half an hour, 3 hours, 4 hours, 10 hours, 14 days. Or one of those saints doing penance on the mountain, you played for 3 years. Maybe it will take you that long. No matter what you do, the number of black balls cannot go to 0. Which means if there is only one ball remaining, that remaining ball has to be white. Or what is the probability that the last ball, what is the probability of A winning? What is the probability that the last ball is white? 0. Last ball, if it is white, that means the number of black balls should be 0. Hello people, I hope you can see me and kind of get to that point soon enough. I'm going to start this. I hope the streaming comes up. Lovely, 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 lovely. I hope the streaming is working now. I'm just going to open the right part of the presentation. Should work. We should be all good to go in a couple of minutes. Wonderful. I hope you can all see me and hear me clearly. In the meantime, I'm going to set this up to take you to a point where I can see you guys. Please type on the chat saying, hey, everything is working fine. Please wait till to reconnect. Please tell me that this connection is working fine. Wonderful. Now I'm audible. Now I'm audible. I'm just going to wait for a few more seconds to make sure that the tech is working fine, the audio is working fine. I think we've done this question, we've done this, we've done this. This question. I think we've done the first 6 questions. Sorry, you had to go through this. The stress of hey, something is completely. Our lights started flashing up and it looked like one of those the evil scenes in the climax of a horror movie. Right, so I don't know what happened. I think our power system crashed, but we have several backups. I think it was a bigger crash across the wider system. Right? It shouldn't have been this sudden, but it did happen. So sorry about that. I am visible and audible. Thank you, Shraddha Satish. Very clear. Thank you. quite good to know that all of you have been hanging in and hoping that hey, this will play out well. Must have been an agonizing few moments. We did discuss a beautiful question, absolutely delightful question with this, where the long and short of it, the last ball simply cannot be black. So what is the probability? What is the probability that A will win the game? Sorry, the last ball has to be black. There's no chance it can be white. The number of black balls can never go to zero. So the probability that A will win the game is zero, which is why we put less than 0.25. Right, wonderful. Can we get back to the question? Of course, we will get back to the question. We are getting back to the questions. I'm going to continue with this further. Right. Wonderful. Let's jump in. I hope you can once again see me and hear me clearly. I'm just going to see if the rest of the systems are working fine. They appear to be working fine. All good so far. I'm going to plug in my other mic to make sure that things are quite fine and dandy. Wonderful. I'm just going to have a look at the chat. So all of you are quite enjoying yourself. You're saying I'm visible and audible. All good, all good, all good. Daksh is there. Daksh is saying, at least from my point of view, I'm assuming he's saying something that's happy, that's making him happy. Clear. Lovely. Lovely. Let's jump this one. It's a beautiful question. Right? Wonderful, wonderful question. How many different integers can be expressed as a sum of three distinct members of the set? 1, 6, 11, 16, 21, 36, 31. Very clear. Right? So in all of these questions, I want to add three numbers from here. I love doing what can be the maximum possible, what is the minimum possible. And what is the maximum possible? Maximum possible is 21 plus 26 plus 31. Minimum possible is 1 plus 6 plus 11. The minimum possible sum is this. Maximum possible sum is this. And all of this, 8, 78. This comes up to 11, 12, 18. The minimum possible sum is 18. Maximum possible sum is 78. Nice. We've got the boundaries of it. We've not come close to solving this question. We've not. I'm just saying, hey, the maximum possible sum is 78. The minimum possible sum is 18. Nice. So far, so good. What else is possible? Hey, I could do 11 plus 16 plus 21. I could do a 6 plus 21 plus 26. Just writing down some possible sums. 11 plus 16 is 27 plus 21 is 48. 27 plus 26 is 53. These are all some of the possible sums. This is the largest possible sum, the smallest possible sum. Right. So now I want to think about how many different integers can be done. Right? So I know I can get 18. I know I can get 48, 53, 78. I'm going to say, hey, I can get 18. Is there a mechanism for me to get 19? Is there a mechanism for me to get 20? I can get 78. Is there a mechanism for me to get 77? I get 18. 1 plus 6 plus 11 is 18. I have to get, there's no way of getting 19. The next possible sum will be 1 plus 6 plus 16. 1 plus 6 plus 16 is 23. It's not 19. 19 is not possible. 18 is possible. 19 I cannot get. 20 I cannot get. That gives me a clue. 18, 19, 20, 21 I cannot get. After 18, the next step is 23. Now I say, hey, this is interesting. Let me look at these numbers. These numbers 1, 6, 11, 16, 21, 26, 31. Nice, very interesting numbers. Why? This plus 5 is this, 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 this plus 5 is this. Brilliant, I'm through. Why am I through? Because if I go from 1, 6, 11 and I want to go to some other sum, I'm going to say from 1, 6, 11, I am moving to 11, 16, 21. I want to do this. What do I mean by moving to? I'm saying, instead of thinking of my three numbers as 1, 6, 11, I'm thinking of my three numbers as 11, 16, 21. 1 gets replaced by 11, 6 gets replaced by 16, 11 gets replaced by 21. Beauty of this is 1 gets replaced by 11 plus 10, 6 goes to 16 plus 10, 11 goes to 21 plus 10. My total is this number plus 30. 18 plus 30 is 48. What am I trying to get at here in a roundabout manner is if I take 1, 6, 11, this adds up to 18. and I replace any one number by another number. So 1 6 11, I go to 1 6 26 or 1 6 31 or 1 26 11. Then I'm taking a number and replacing it with another that is more than it by 5 or 10 or 15 or 20, or less than it by 5 or 10 or 15 or 20. Any two numbers in this list, the difference between them is 5 or 10 or 15 or 20. Instead of 11, I put a 31, my sum will increase by 20. Instead of a 26, I put a 16, my sum will decrease by 10. Or quite beautifully, if I have one sum as 18, another sum as 78, I can go to a final that is 23. I can move to a 28. I can move to a 33. I can move to a 58. I can move to a 63. I can move to a 68. Whatever these sums are, I can do plus 5 minus 5 plus 10 minus 10. If I have one sum, I can go to plus 10, I can go to minus 10, I can go to plus 5, I can go to minus 5. I can find a sum that is plus 15, I may be able to find a sum that is minus 15. Nothing else is possible. Nothing else is possible. Or my numbers are moving in steps of 5. My totals will also move in steps of 5. I am through. How am I through? Now I know how to fill the numbers between 18 and 78. 18 is possible. 23 is possible. 28 is possible. 33 is possible. 38 is possible. 43 is possible. 48 is possible. 53, 58, 63, 68, 73. How many different how many different integers can be expressed as sum of three distinct members of the set? All of these can be. How many are there? I can just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All move in steps of 5. I can think of this 18 as 3 into 5 plus 3. 23 is 4 into 5 plus 3. 28 is 5 into 5 plus 3. All the way till 78 is 15 into 5 plus 3. They all move in steps of 5. Writing each number as a multiple of 5 shifted out by a little. So from 3 to 15, 15 minus 2, 13 different numbers are there. 13 numbers, 13 possible sums are possible. The key thing to notice, the minimum sum is 18, maximum is 78. It doesn't mean anything in between can be done. I cannot find some three numbers here that add up to 26, to 34, to 50. I cannot. Only possible sums are 18 plus 5 plus 10 plus 15 plus 20 plus 25 plus 30 plus 35 all the way till 78. The sums are all from 18 to 78, all numbers that differ from either one by a multiple of 5. That's the crucial part. So all numbers like 18, 28, 38, 48, 58, 68, 78 and 23, 33, 43, 53, 63, 73. All numbers ending in 8 and 3 between 88, from 18 to 78. That's all we are counting. So beautiful, beautiful question. 13 different sums are possible. Wonderful. I think there's somebody who's saying, Sangeeta Vijay says, I have a doubt. Go for it. It's a beautiful question. It's a wonderful question, which is 7 into 6 into 5 wrong? Actually, why 7 into 6 into 5 is wrong? You're looking at all of these numbers and saying, hey, the first one can be chosen in 7 ways. Second one can be chosen in 6 ways. Third one can be chosen in 5 ways. The problem there, first step, is whether you're counting 1, 11, 16 or 11, 1, 16 is the same. So that's an issue there. More than that, 6 plus 11 plus 16 and 1 plus 11 plus 21, both are going to be same. Different ways of selecting the three numbers, but the sums could be the same. When you roll a pair of dice, the first outcome there are 6 possibilities. Second outcome there are 6 possibilities. 1 to 6, 1 to 6. But the totals can go only from 2 to 12. Only 11 possibilities are there. 6 outcomes possible here, 6 outcomes possible there. The total there are only 11 possible outcomes. And so it's very important to have one eye on where the total can sit. That's super crucial. Gatik Sarapatsum, I have a doubt. Go for it, Gatik. I think Sauradeep Das has explained that issue quite brilliantly. 611, 16, 111, 21. Wonderful. I'm going to go to the next question. We are already behind, so I'm going to rush through and finish this up. Consider a 104 digit number 48, 49, 50, 51, 52, 53, all the way to 19. It took me a while to understand that this is a 104 digit number. From 99 minus 47, 52 2-digit numbers into 2. From this, we drop 52 digits, exactly half of them. What are the first 10 digits of the largest possible 52 digit number? First thing, the exam did not read, this question did not read exactly like how it is reading now. The exam said find the largest 52 digit number. Write a long number. Sorry about that. Write only the first 10 digits. It's a beautiful question. And so the end number, so 48, 49, 50, all the way till 99. Obviously, we are removing 52 digits. 52 will remain. I know my final answer is a 52 digit number. So what do? I want my 52 digit number to be as high as possible. Or since the number of digits is the same, first thing I know, I need to start with a 9. Yes. If I start with I have a 52 digit number. I want a very large 52 digit number. I want to start with 9. So what will I do? I'll drop these. I don't want them. If I have them, then I can't start with a 9. I want to start with a 9. Immediately I know the next thing. I want my next digit to be 9. Of course, I want my next digit to be 9. First digit is 9. I want the second digit also to be 9. Why? Because I want the number to be as high as possible. So what do? I look at this 9 and I go, after this 50, 51, 52, 53, up to 59, there are no 9s. Dump everything in between. I don't care about any digit. If I cannot have 9s, then I'll think about can I get to an 8 or a 7 or a 6. But as many of the digits being 9 originally, happier I am. First of all, I'll say this 48, 49, 484, I'll kick out. I want to start with 9. After that, what will I say? I'll kick out everything till my next 9. So I want to go 50, 51, 52, all the way till 59. I'll kick out all of these digits. I have that 9. And then what will I have? 60, 61, 62, all the way till 69. I'll kick out all of these and have that 9. I'll go to 70, 71, 72, 73, all the way till 79. I'll kick all of these and have that 9. And keep on doing that. Hey, I can keep on doing this, but hey, I can kick out only 52 digits. So I cannot keep on doing this. I have to do this and then take stock. Maybe I'll do this, able to do this twice, thrice, 4 times. Wherever I can go till, I'll go till that point, then I'll take stock. Right? So let me start with 50 to 59. 10 numbers here. 10 2-digit numbers, 20 digits, of which I need to kick out 19 of them. From 50, 51, 52, 53 till 58. And then this 5 I am kicking out. So I am kicking out 19 digits here. Can I kick out another 19 here? Yes. First I kick out 3. What are these 3 digits? 4, 8, 4. 48 and 49. Then I kick out 19 to get my second 9. I kick out 19 to get my third 9. So I'm at 9, 9, 9. I've kicked out 3 plus 19 plus 19. 3 plus 19 plus 19. 3 plus 19 is 22. 22 plus 19. So far I've kicked out 41 digits. 38 plus 3, 41 digits. I need to kick out 52 digits. First thing I realize is I cannot kick out 19 more digits. Not possible. My fourth digit, not 9. Cannot get a 9 here. I simply cannot get a 9 here. Because I have kicked out 41 digits. I have only 11 more digits to kick out. My next 9 is 19 digits away. I cannot get a 9. I'm in trouble. It doesn't work for me. I cannot find that. So what do? Hey, nice, interesting, beautiful. Therefore, now I'll start from 70 and know that I have to kick out 11 more digits. So I'm going to start from here: 7 0 7 1 7 2 7 3 7 4 7 5 7 6 7 7 7 8 7 9. I have only 11 digits left with me. I cannot go and find this 9. Not possible. I'll look to get this 8. If I have to go till this 8, I have to delete all of these. Possible, because 2, 4, 6, 8, 10, 12, 14, 16, 17 digits I have to kick out. I don't have 17 with me. I have only 11 that I can kick out. So my next digit has to be a 7. I have to have a 7. Otherwise, I cannot work with. I cannot get a 9. I cannot get an 8. If I have to have a 7, I don't need to kick out everything till here, because I can kick out the 0, 1. These are also 7s. I don't need. Hello, hello. I think for some reason I went on mute. Audio went off. Sorry. I hope now you can hear me. I hope the audio is back on track now. Several things seem to be becoming funny today. Just want to fix this. Hello, 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 hello. Now audible. Lovely, 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 lovely. Wonderful. Now it's audible. Let's continue on with it. Something seems to have gone wrong with our Bluetooth settings. Sorry about that. So I'm going to recap this. I'm going to revamp this. And so you need to get 19 digits out to get the second 9. 19 more to get the third 9. Another 19 we can't kick out. We cannot get to this fourth 9. So what do? We say, let's kick out till this point. Let's kick out 50 to 59 ka 5, 60 to 69 ka 6. Then we'll take stock. So we are at a point where we have kicked the first 3 digits out, 484, gotten our first 9, second 9 by kicking these 19 out, third 9 by kicking these 19 out. We cannot get a fourth 9. The fourth digit cannot be a 9. Okay? So we have kicked out 3 plus 19 plus 19, 41 digits out so far. We can kick out 11 more. Right? But to get to this 9, we have to kick out 19 more. Not possible. To get to this 8, also, we have to get out 17 more. We don't have 17, we have only 11 digits to kick out. So you know for sure this digit has to be a 7. So what do? If it's a 7, I don't have to get these 2 7s. I can kick out 0, 1, 2, 3, 4, 5, 6. I'm through. So if I kick out 0, 1, 2, 3, 4, 5, 6, and then this 7 also, and then this 8, I can get a good combination. I can get a bunch of 7s. I can get 999, 77, 77, 77, 77, 77 merrily. And so how many digits have I kicked out? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But hey, if I do that, I'll be kicking out an 8 and a 9. Do I really want to kick out an 8 and a 9? Is it really required for me to kick out an 8 and a 9? Maybe not. Maybe I want to keep that 8. So I want to now, I'm going to change my strategy and say I'll kick out 0, 1, 2, 3, 4, 5, 6. 6 digits I kick out. And then I'll say I want to keep that. So what will I do? I'll kick out these 3 sevens and retain that 8. Then what will I have? 7, 7, 7, 7, 70, 71, 72, 73, 74, 75, 76. All of these are 7s. Then I kick out these 3, I'll have 8 coming into the picture. So I can have 999, 777, 7777 and 8. Can I do even better than this? Can I get even one more position forward for the 8? Yes, I can if I kick out this 7. So now I'm going to come back to this. Only focus on the 7. 70, 71, 72, 73, 74, 75, 76, 77, 78, 79. 20 digits here. I need to kick out 11. I don't want anything from 0 to 6. That is clear. So there are 0, 1, 2, 3, 4, 5, 6. These are out. 6 digits are out. I want my 8 as high up as possible. As high up as possible. I've kicked out 7 digits. I have 11 digits totally to kick out. What will I do? I'll kick out and this. So that my 8 can come up as advanced as possible. As much forward as possible. So what will I have remaining? 1, 2, 3, 4, 5, 6. Then 8, 7, 9. My first few digits, first 3 were 9. So I have 999, 77777, 879. That's my first few digits. I want to get the first 10 digits, 3 9s, 6 7s and an 8. Extremely difficult question. Very careful we've got to be. First we need to find our first 9, kick out 484. Then the second 9, 50 to 59 is 5. Third 9, 60 to 69 is 6. All the digits. All 19 plus 3 plus 3, 41 digits going out is very easy. Not very easy, but still doable. I have 11 more digits with me that I need to kick out. I go step by step. I realize that I cannot get to a 9 or an 8. So I need to have a bunch of 7s. So if I have to have 7th, I want to remove everything else. I remove 0 to 6. The moment any one of these comes, I'm in trouble. 0 to 6 I remove. After that I say, hey, I've removed everything from 0 to 6. Is there a way I can bump up this 8 as high as possible? Knock off 4 more 7s. These 3 and this one also. Brilliant. So 3, 9, 6, 7 and an 8. That will be the best combination. Absolutely delightful question. Really difficult. Sachikala Ramkumar, the question that was asked in the exam was the largest possible 52-digit number, not just the 10 digits. Yes, I know that. Very important. And we got that wrong. So we should have made the question to be this simple so that you can write down the answer. But hey, don't worry about it. It is, if you have tried this question, it's still all right. Kushpreet Singh, Punjabi nahi aati. That was asked in the exam was the largest possible. Yes, I think I have answered that. Question is wrong. Correct. Question was wrong. Don't worry about it. Question was wrong. That's all right. Wonderful. I'm going to go to the next question, which also promises to be intriguing and difficult. I'm going to have a look at the chat with our volume window. Volume seems to be working fine. Brilliant. Let's go to the next one. 4 mathematicians, P, Q, R and S meet for dinner. They're each given a hat that has an integer printed on it. The difference between the maximum and minimum of these integers is 11. Each mathematician sees the other 3 numbers but cannot see his own. Very interesting. P says the sum of the 3 numbers I see is positive. Nice. Q says the sum of the 3 numbers I see is negative. So Q plus R plus S greater than 0. P plus R plus S is less than 0. So to R plus S you add P, it is negative. To add Q, it is positive. Fine. So Q is greater than P. The product of the three numbers I see is positive. So P, Q, S is greater than 0. The product of the three numbers I see is negative. P into Q into R is negative. What is the maximum possible value of the sum of the four numbers? This is tough. I'm going to write this down all over again. Q plus R plus S is greater than 0. P plus R plus S is less than 0. P into Q into S is greater than 0. P, Q, R is less than 0. To PQ, I multiply with S, I get positive. I multiply with R, I get negative. Q plus R plus S is positive. P plus R plus S is negative. And so P is less than Q. To R and S, I add P, I get the sum to be negative. To R and S, I add Q, the sum is positive. Right? We want the overall sum to be as high as possible. So it is quite likely that we should want Q to be positive. P plus R plus S is negative. Q plus R plus S is positive. So the overall sum is P plus R plus S plus Q. So I want Q to be positive. I want the sum to be as high as possible. I want Q to be positive. I want the sum to be maximum. So I don't want to deal with a scenario where Q is negative. Then P will also be negative. Then P into Q into R is negative. R will also be negative. Only S is positive. Then P plus R plus S plus Q will become a negative number. I want my total to be high. So straight away I am saying P plus R plus S is negative. If I want my total to be higher, Q has to be positive. So I am putting Q as positive. Right? So Q is positive. So P into S is greater than 0. P into R is less than 0. Q is positive. So out of P and S, one is P into S greater than 0. P into Q, P into R is less than 0. I have decided that Q will be positive. Well, I want my total to be as high as possible. So P into S is greater than 0. P into R is less than 0. P can be negative. S can also be negative. Or P and S both are negative. So we can have a scenario where among P, S, R, you could have positive, positive, negative, or negative, negative, positive. Positive, positive, negative, or negative, negative, positive. S and R should have opposite signs. So positive, negative, negative, positive. P is positive, P is correspondingly positive, negative. Brilliant. Q plus R plus S is positive, P plus R plus S is negative. When P, R, S is negative. So I can have a scenario where P plus R plus S is negative, like this or like this. And I want to find P plus R plus S to be negative, but as high as possible. And so what do I want to do? I want to do P plus R plus S to be minus 1 and Q to be as high as possible. P plus R plus S to be minus 1, Q to be as high as possible. That's my objective. If I put P plus R plus S to be minus, because I know P plus R plus S is negative. If I can figure out a way to make it minus 1, just minus 1, I'm very happy. Then that's my best possible scenario. And Q to be as high as possible. I plonk a Q to it, it will fly. And so P, S, R, 2 positives and 1 negative, or 2 negatives and 1 positive. And so P, R, S, all three. Let me see if there is a mechanism to make. I also know the smallest number to largest number. The difference between the maximum and minimum is 11. So let's say the minimum, I want to keep it as minus 1, because otherwise it becomes tricky. I put this as minus 1. This also is minus 1. P plus R plus S is minus 1 I want to do. P is minus 1, S is minus 1, R is plus 1. Maybe this will work for me. P minus 1, S is minus 1, R is plus 1. So P is, let me see if all conditions are satisfied. P plus R plus S is negative. P plus R plus S is negative, minus 1. P into Q into S, Q is positive. P into Q into S will be positive, yes. P into Q into R will be negative, yes. So minus 1 plus 1 could give a total to be minus 1. This is largest possible negative total. The smallest possible the negative number, I need to have a negative number. I'm putting the negative number as minus 1. Only then Q can be as high as possible. Maximum to the smallest to largest number, the difference is 11. So Q is minus 1 plus 11, which is 10. I could have a scenario where P is minus 1, Q is plus 10, R is plus 1, S is minus 1. Some of the three numbers I see is positive, 10 plus 1 minus 1, that works. Some of the three numbers I see is negative, minus 1 plus 1 minus 1, that works. Product of the three numbers I see is positive, minus 1 plus 10 minus 1, yes, product is positive, that works. Product of three numbers I see is negative, forget this, 10 into 1 into minus 1, that works. P plus R plus S is minus 1, that is the best possible scenario, negative but the maximum possible negative number. Q is as high as possible, there cannot be a number more than 10, we definitely have a negative integer. We have a minus 1 for sure, at least one minus 1. Minus 1 plus 11 is 10, so we cannot have a number more than 10. The maximum possible number possible is 10. The maximum possible sum of P plus R plus S is minus 1. We cannot have a scenario better than this for the sum to be as high as possible. In this case, what will be the total? Minus 1 plus 1 is 0, 10 minus 1, 9. Or this is the best case scenario. Minus 1 plus 10 plus 1 minus 1 PQR is absolutely delightful question, in which case the total of all four should be equal to 9. Lovely, just having one look at the chat window, nothing new there. We'll go to the next question. A teacher wrote the numbers 1, 2, 3, 4 till 2022 on the board. One of the students erases m of these numbers. Among the numbers remaining on the board, not a single one is a product of any two of the others. The smallest possible value of m is x, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, all the way till 2022. I come here and I erase a few numbers. Right? And then let me see, suppose I say, hey, such that not a single one is a product of any two of the others. Right? But I want to erase the smallest possible such numbers to keep this. First of all, I look at this and say I should keep all prime numbers. Prime numbers don't bother anybody. And so because prime number cannot be written as a product of two numbers. So I keep 2, 3, 5, 7, they don't bother anything. So if I keep all prime numbers, it should be good for me. The problem is if I keep 2 and 3, I cannot keep 6. If I keep 2 and 5, I cannot keep 10. Product of two prime numbers, they can create trouble for me. It becomes a problem. So suppose I have a 3, then I'll have to worry about every multiple of 3. If I have a 6, I can't have an 18. If I have a 4, I cannot have a 12. If I keep a number, then automatically it's like all its multiples get highlighted. If any one of them comes in trouble, I'm in trouble. So I have 3. Between 4 and 12, I can have only 1. Between 5 and 15, I can have only 1. Between 6 and 18, I can have only 1. So every time I select a number, then a bunch of numbers get paired up, we get combined. So I'm going to think about, okay, 1, 2, 3, 4, 5. I'm going to think about, okay, let me think, I'm not erasing 2. I'm not erasing 2. That means if I have 3, I cannot have 6. If I have 4, I cannot have 8. If I have 5, I cannot have 10. If I have 6, I cannot have 12. If I have 7, I cannot have 14. What will I do? I'll say, okay, I cannot afford to have 3, 4, 5, 6, 7. So many numbers are getting eliminated. Let me keep 6, 8, 10 and all that. If I have 6, I cannot have 12. So if I keep 2, 2 is a nice juicy number as a prime number. 2 cannot be written as a product of two numbers. But because I have 2, I have so much trouble. 2 creates a giant list. At the same time, if I have 2021, I I may be alright. 2021, I may not be able to write it as a product of two numbers, but at the very least, 2021 into something will never be on the list. 2022 by 2 is 1011. Suppose I take any prime number above 1011, I am good. In practically many odd numbers above 1011, it will work for me. I don't have to eliminate them, they are not causing trouble. Initially, my idea of prime numbers are good, composite numbers are bad. And I am changing my idea. I am saying 2 creates so much trouble for me. Let me kick out 2. Having 2 creates so much trouble for me. Let me kick out 2. I don't want 2. First, I'll erase 2. If I erase 2, then I am very happy. 3. If I have 3, I can continue to have 6 also. If I have 4, I can continue to have 8 also. Now, I go to the next step and say I have of this 1, 2, 3, 4 till 2022. I am definitely erasing 2. 2 causes so much trouble. I don't want 2 on the board. Now I come to 3. 3 into 4 is 12. If I have 4, I cannot have 12. If I have 5, I cannot have 15. If I have 6, I cannot have 18. Again, I am in trouble. So I don't want 3 either. 2, 3 are small prime numbers. Small prime numbers are a pain. It's not prime. Small numbers are a pain. 4, if I have 4, I have 5, I cannot have 20. I have 6, I cannot have 24. 4 is also a pain. 1 is a pain. Is 1 a pain? Product of two numbers, yeah, it will be there. 1 is a pain. 1 has to be kicked out. Straight away I sense that small numbers equal to pain. Large numbers give me happiness. Nice, now if you have small numbers, they'll keep on all their multiples you have to worry about. If I have 7, then 7 into 8 is 56. If I have 8, I cannot have 56. I'm always looking over my shoulder if I have small numbers. So what do? I say, take a big board and say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, I keep eliminating. I eliminate the first 20 numbers. First number is 21, 22, 23, all the way till 2022. Now again I think, okay, I have a 21. 21 into 21 is 441. 21 into 22 will be there on the list. 22 and 23 will be there on the list. I say, okay, let me take this through to completion. I cancel this also. I take it to a point where I keep only eliminating small numbers, but I reach a point where, say, 35 I go to, 35 into 36 is less than 2022. I don't want that. I keep eliminating. 2022 is close to, let me just try it out, 40 into 41. 40 into 41 is 1640. I need to go bigger. 44 into 45. 44 into 45, I didn't know, 45 into 44. 180, 180. 1980. So 44 into 45 could work. I eliminate everything till 45. Get everything out of the way. So 46, 47, 48, 49, all the way till 2022. If I have this with me, 46 into 47 will be more than 2022. Even 45 into 46 will be more. I eliminate all numbers from 1 to 44. I got this covered. If I can do better than this, then I have to worry. If I can't do better than this, then I am covered. What are my choices? My choices say less than 50, 49 to 99, 100 to 151, greater than 150. This works for me. I eliminate the first 44 natural numbers. I'm happy. If I eliminate 1, 2, 3, 4, 5 till 44, I'm happy. The key to here, this question itself is saying small numbers are a pain, large numbers are okay. Eliminate small numbers till you don't have to eliminate anymore. So eliminate everything till 44, we are covered. X less than 50, that's the answer. Again, excellent question, exceedingly tough question, beautiful question. Right? With that, I think we're pretty much done. Thank you for hanging in. We did get delayed. I know you're all anxious to, curious to get the answers. Please, you can check out the results in maybe another 10 minutes, 15 minutes. We have a fabulous summer camp if you want to do this summer. The summer camp effectively is going to be just this Olympiad into 6 into 5. So we do a bunch of questions which are interesting, beautiful, which talk about a different way of thinking. We talk about a slightly unconventional style of questioning. We'll take those questions, we'll modify them to make it relevant to you guys and have fun. Every day we'll do a 10 question session where we do 10 beautiful questions like PiMO and then discuss them. So it's going to be like PiMO, the additional benefit being we'll have a more intimate group than a YouTube session to discuss this. We'll have a good peer group where you guys can talk with each other and know what else everyone is doing. It'll be a couple of hours a day, 6 days. The timing, schedule, everything is available. If you register within March 5, you get a juicy discount as well. So what I want to do for math learning, I want to make sure that people love math. Kids get pushed hard where they do solve lots of tough questions and then see if they can discover a new method and pick themselves up to figure out something new. So the entire PiMO was built with that idea. The summer camp is a further expansion on that idea. That you do something slightly different, slightly unconventional, something atypical, and it opens up your mind and says, hey, I can think differently about this. And creating that challenge and having fun with that discussion, that's my job. So all of you guys, I hope you jump in and say, this is fun, PiMO was fun, PiMO'22, that should be awesome fun. Jump in and we'll have loads of fun during the summer camp. Right? So those of you who are parents who are sitting there, if you have any questions about what you want to do in the summer camp, please ping. We will take you through what we are going to do in the summer camp. I know all of you are anxious to get the numbers and marks and results. Don't worry about numbers and marks and results. I can tell you this much, the scores are much lower than what you might have expected. The exam is tough, really tough. If students have got 2 out of these 10 right or 3 out of these 10 right, you're doing really well, exceptionally well. You're doing 4 or 5, phenomenal. These questions are properly tough. If you can attempt them, if you can understand the solution, if you can have fun having a go at it, then several of your objectives have been automatically achieved. So don't look to push yourself and say, I need to get 8 out of 10 right or 7 out of 10 right. That is not a requirement. So the scores will be released. You should be able to see that. Have fun going through the answers in your scorecard, but don't have an expectation as to what should be a good score, what should be a great score. Don't work yourself up with the score target in mind. It's not relevant, it's not important, it's not crucial. Right? Wonderful. So how do you check the results? Just go to math.piverb.com, click see results, you should be able to find that. So back to the summer camp. We had a summer camp last year as well. It was super fun, super duper fun. It was so much fun that quite a few of our students attempted multiple summer camps. It just come, not strenuous, it's not an 8-hour journey, a couple of hours. Do a set of 10 questions, be intrigued by them, be pushed hard, find it challenging, but enjoy the result and discussion part. Have fun in the overall learning process. Add a bunch of thinking ideas in mind, you're good to go for the next year. So it promises to be awesome fun. I'll make sure that it is super challenging. I'll make sure it's super fun. Not because of some new different thing we'll do, but because we'll discuss math interestingly. I'm a firm believer that if something is done with full enthusiasm and with the level of challenge thrown in, it is awesome fun. Something is too straightforward, too simple, it gets boring after a while. It has to be at the point where it is tantalizing, where you feel like, look, I can have a go at it, but the method is not obvious. It is my job to create a bunch of questions where they are solvable, but the method is not obvious. My expectation from you guys is to have boundless enthusiasm and curiosity to keep on trying different things and just not feel bad if 5 of your tricks don't work, 6 of your tricks don't work. Right? Wonderful. All the best to all of you. I had quite a bit of fun setting the paper and having fun discussing it. I'm going to give you more to the results part. Yeah, a lot of goodies given away. So I think between Avinash, Bala, Raghu and Lakshmi Narasimhan, they've come up with a bunch of very good prizes. You get access to a wonderful masterclass series from PiVerb, and you get access to a good boat speaker. And so that should be fun. PiMO 2022 winner, Abhinav Ketan. Exceptional performance, wonderful, wonderful. Many congratulations to you. Hope you go ahead and have lots of fun in life and learn tons of stuff. Keep your curiosity with you. Keep your mathematical ability with you. Your eyes evidently light up when you see good questions. Keep that habit with you. For the rest of you, I think there are several who have performed exceptionally well, quite brilliantly, quite magnificently. Keep at it, learn newer ideas, keep adding them to your basket, do well. All of you will get a certificate like this where it says, hey, you've participated in this and done well, you've performed well in this. So you will all get the certificate. So pick that up. Most definitely, like this video, like our channel, subscribe to our channel, share this, spread the word about us. I want to have some glorious fun in this summer. I can't wait for this to happen. 2021 has been a little bit of a meh year, not been a great year. We've all been locked up and getting wound up. 2022, let's have some fun. I don't know how much fun you can have traveling and going to different places even this year, but I'll make sure that the time you sit here and participate in the summer camp, that is awesome fun. Couple of hours each day, doing some wonderful puzzles, having fun discussing them, what's not to like. Right? Beautiful, folks. Congratulations to all of you for hanging in there and enjoying the learning process, which is beautiful. Keep this attitude of enjoying yourself and learning with you all times. And I look forward to catching up with as many of you as possible during the summer. I'm here for some questions, so if any of you has any queries, any questions, please ping. Oh, there's an outpouring of congratulations, Abhinav. That's brilliant. The attitude is, it fills my heart with joy. So many of you have such wonderful, good, kind words to say to your peers. It's going to take you places. You should be able to see your answers and leaderboard and scores and marks and all of that. Less relevant. That is less relevant. What is more relevant is being able to see the solution and enjoying the process of picking up new ideas. Please do that. Any questions on summer camp? Ping us. You can reach out to us on several platforms. This is number, email address, that place. You can send us a WhatsApp, text, SMS, anything works. Any queries, please do ping us. We're only too happy to answer. If any parents, you have any queries about how challenging it will be, how simple it will be, how we can plan this, schedule this, we are here to have the conversation. Please do ping us. Vineet, Neb, I have a doubt. Go for it, Vineet. I don't know what several of those symbols mean. Abhisha George and Sayan Das and King Whitey Game. I don't know what those symbols mean. I presume you're all saying good. How are you a math genius? I'm quite far from being a math genius. I enjoy math, and I've done puzzles and math problems all my life. More than that, I enjoy creating questions and teaching. So I think the part that I enjoy teaching is more relevant. I'm not as good at solving very difficult questions as I am in having fun and carving open new questions for young students. Padmini J, thank you for your comment. Thanks for the compliment. Just now when I thought I couldn't figure out some of these symbols, new symbols keep coming. I think Next Gen Magic has sent in what looks like a candy. Dinesh, how should you check results? You could go to math.piverb.com, click on PiMO', you will be able to see the results. I think all of you will have the credentials already. Meet Neb in exponents and power. The doubt is to simplify, expand this in expanded form. 279404. I don't know how you do that. Divya Pranaji, fantastic PiMO' question. Thank you. Looking forward to the summer camp. Me too. I can't wait for it to begin. Who are in the top 10 in PiVerb 2022? I think that should be available on the leaderboard. You can have a look. Once again, don't worry about the top 10, top 6, top 5. It's not like one talk show or a music board. Right? So, did I have some fun? Did I learn some new ideas? Those should be your defining questions. King Whitey Gamer says that he wants it mentioned that his name is Arvind. Good, Arvind. Neil Mantri enjoyed and learned. Yeah, you tick those two boxes, you can go places. Enjoyed the session, had fun during this process, had the curiosity kindled, the interest peaked, whatever you want to call it. Had fun, learned a bit. Those are the two objectives. Everything else is secondary to that. Wonderful, folks. With that, I'm signing off. Have a good Sunday. Enjoy yourself. Keep rocking and enjoying the math part. Ciao.